Hi guys. Okay, so in this video, we are going to look at the homework problems 25 and 27. And here in the problem number 25, these are looking at the calculations based on the correct number of significant figures, writing the answer based on that. And then the 27 and 25, the 25 relates to multiplication and division, and the 27 relates to addition and subtraction, okay? So let's do these. We know the rules, first of all, that anytime you are doing the calculations where the significant figures are involved, so when you do the multiplication and division, okay, multiplication and or division, in that case, the final answer will have the lowest significant figure, okay? That was in the computation. So that's the rule. So don't forget that. Final answer will have the lowest significant figure. That was in the rule. That was in the computation. Okay. So here we see that so this is part A, 45.7 multiplied by 0.034. So here we see we have three significant figures from here, three significant figures, and we have 0.034, so only two significant figures, okay? So clearly, just by looking at these two significant figures and three significant figures that are in the computation, your final answer in this case should only have two significant figures, okay? So two significant figures in this case. So let's do the multiplication. Okay, so from the calculator, I get this number, 1.5538. Now, here's the thing. According to the rule, we only need to have two significant figures. So here we will need only this, and we need to keep 5. But we need to drop 5. So when we drop off 5, so what happens to the remaining 5? The remaining 5 on the left. So the other 5, so this one, we add one more, and this becomes 6. So your final answer now is equal to, so write down here, always answer is equal to 1.6. And if there are any units, you write down those units. Okay, so that's how you get 2. Now let's look at the second one. Now here we are going to use the PEMDAS rule also. So don't forget that, PEMDAS. So PEMDAS is, please excuse my dear Aunt Sally. So please, parenthesis, right? E exponents, M is multiplication, D is division. So clearly these two numbers are, if you look at the factors, if you understand the factors, this is division, dividing, and this one is multiplying. So we need to multiply, and then, so here's another thing. Let's count the significant figures, first of all. So let me write this again. So 0.2465 multiply by 25. Okay, and then divide that by 1.78. So here we see we are going to leave 25. We are not going to count that because it's an exact number. So do not consider exact numbers. Do not consider exact numbers in, in calculating for the like calculations when it comes to significant figures. If all of them are exact numbers, then yeah, we would do that. But here we eliminate them. So we only look at the ones with the decimal places. Okay, so it's all, the significant figures, the rules. The exact numbers is exact, like it's very precise, it's exact. But the rules which relate to the significant figures apply more to the decimal places because there is some uncertainty, right? So because of that. Okay, so anyways, here we have 1, 2, 3, 4. 4 significant figures here. And here you have 1, 2, 3. 3 significant figures here. Okay, so ideally we should have 3 significant figures, but we can also get 2 significant figures also if we bring the 25 also. So, it depends. Sometimes the books, they use that, sometimes they don't. So I've seen all these variations. So anyways, let's look at the answer first of all. Okay, so here, as I was telling you, that do not consider the exact numbers in calculating whenever, for the final answer, when the final answer has to have a certain significant figure. And the reason why is because here's the thing, because these exact numbers have variable significant figures. So when we are looking at, especially in science, and also it depends in what context you're using the measurements, and when are you using, or who is using, and how much of the uncertainty is allowed. So kind of the more significant figures you have, the more like sensitive that data is, the more precise you are, the more the more towards the exact, more precise the data is. But the less significant figures you have, that means, there's less uncertainty, like there's a less precision, there's less sensitivity in that data. So I just checked it. I see that the answer is giving in the book is 2 significant figure, which is fine because that would be the lowest, right? Which is fine. But if you want to have a little bit more sensitivity in your measurement, then 3 is ideal. Okay, in this case also. Okay, so use your judgment. So it's not like, you can look at it in what context you are using these calculations. Okay, so now here again. Now, on the exam, if you might be asking me on the exam which one we should take and all that, so my rule is just follow this one. I want you to have like a little bit more precision, more sensitivity in the data. So it's best to avoid, just keep things more exact. So exact means more significant figures, like the maximum number you can get. So we see the minimum number based on the decimal places. Okay, so we are going to look at the 3 significant figures here first, and then we will look at the 2 also. Now there's another thing. When I did this calculation in the calculator, 0.2465 multiplied by 25, I get this number on the calculator. Write down the number as it is. Okay, write the number as is, you see, from the calculator. So when you do that from the calculator, right now, do not round up or round down, or, do not do any rounding, because rounding brings in uncertainty. Rounding is just, estimating, just beautifying the numbers. Okay, so here you see that these numbers are 6.6125 divided by 1.78. So here we need 3 significant figures in the answer. So let's do this calculation. Okay, so from the calculator, I get this big number, 3.4620786, and then there were many numbers also, so but which I have not included. So here we need, from the rules, 3 significant figures, only 3 numbers. So we are going to keep it as 3.46. So this is the 3 significant figures. But if you just want to say, okay, somebody says, oh, just keep it at 2 significant figures, that is also an option. So what will you do? So here, let me make this bigger. So in this case, you will have to only keep 3, 4, and you will be dropping off 6. So when you drop 6, and 6 is more than 5, so 4 becomes 5. So then in that case, the answer is 3.5. And this is 2 significant figures. So it all depends, in what context you're doing the measurements. So you see round 0.6, 0.4, 0.5 in chemistry, it means a lot, right? It's milligrams. If you put the salt on the weighing machine, you will see that 0.4, if you measure something as 3.4 versus 3.5, that teeny bit extra, that little crystal will have, some weight, and that can contain thousands and thousands and thousands of molecules. You understand that? So that's why. So for chemists, we have to be very sensitive. Same thing, like if an engineer is using this data, this measurements. So for them, they need to have, like, if you have 3 places after the decimal or 2 places after the decimal, the data is more sensitive. If 1 place is after the decimal and on top of that it's rounded up, it's not very sensitive. You get that idea? Okay, so this is what I wanted to tell. Okay, so it's always applications, you know, of the applications of the concepts. Okay, now let's look at question number 27. Now question number 27 deals with the additions and subtraction. So let me write that down. Okay, so here we see we perform each of the following calculations and give an answer with the correct number of decimal places. Okay, so here I'm going to do one for you. The other questions are already given. So 45.48 centimeter plus 8.057 centimeter. Okay, I'm going to do one. The rules are the same. All right, so here you see, sorry, I add, so when you add and subtract, so in this case, we see that the final answer should have the lowest or the least decimal places. Okay, least of the decimal place. Okay, so these least decimal places, when we add and subtract. All right, so that means you're going to now count the decimal places here, not the significant figures, but the decimal places. So we see we have 1, 2, and 3. 3 decimal places here, and I'm going to put it like that. And the second one is 2 decimal places. Okay, so 3 decimal places and 2 decimal places. So your final answer should have 2 decimal place. All right, so now let's do this addition. So here we have 7, 8, 13, 5.13, 5. Okay, so this is your answer after you add. All right, now what do? We need to keep only 2 decimal places. We need this, we need this. So we need to drop 7, but 7 is more than 5. So what happens to 3? Therefore, 3 becomes 4. So now your final answer is 3.54 centimeter. Always write the units. All right, so this completes the second section, the second part. So you see all these problems I have given, these are all based on the individual, like, separate sections. So this was one, this is the next. Now we're going to look at the next one, 43, 47, and so forth. Okay, so let's look at the next one in the next video.